Hi guys, welcome to chemistry class with Sir Anselm. Last time we were discussing a topic, homologous series, the functional groups, the general formula, and a member, a typical member. We discussed over 4 homologous series last time. But I want to remind us what homologous series means. A homologous series is a family of organic compounds whose members have regular structural patterns in which each successive member differs from the other by a CH2 group and the 14 atomic mass unit. You know that the atomic mass of carbon is 12. That of hydrogen is 1 times 2. We have 12 plus 2, which is 14 atomic mass units. So that is the only difference between two members of a homologous series. So a homologous series is just a group or family containing many organic compounds that are similar, and their similarity is just the functional group. And this functional group is what determines their chemical properties. Functional group can be a group of atoms, or an atom, or a bond common to homologous series that determine the chemical properties of the members. Now, today we want to look at 3 homologous series. Last time we discussed alkanes, alkenes, alkynes, alkanols, alkanals, alkanones, and alkanoic acid. Today we want to look at alkanoids or esters, amines, and amino acid or alpha amino carboxylic acid. So let's go straight to alkanoid. What's an alkanoid? An alkanoid is a homologous series whose general formula is derived from alkanoic acid, which is RCOOH. Recall that in our previous video, this was about the last homologous series we treated, alkanoic acid, COOH. Now, to get an ester, the hydrogen in alkanoic acid, the hydrogen bonded to oxygen is going to be replaced by a substituted alkyl group. So this is the general formula for esters. Now, to get the functional group, is just to remove the alkyl group, the main alkyl group, and we have COOR prime. This is the functional group. You can write this general formula as, you can condense it as RCOOR prime. The same thing. You can also condense this one, COOR prime. Now, let's get a member of the group, a member of this family. You can get a member. Remember that this is a bond linking to a group. That group is alkyl group, but it is not necessarily alkyl group, because once the functional group contains carbon, it means the compound is organic compound. So you can put hydrogen or alkyl group. But in this case, let us put one of the alkyl groups, methyl group, CH3. Then we link our COOR prime. You can condense it as CH3 COOR prime. But no need of putting R prime. You will also replace the R prime. Let's replace it by CH3. CH3. So what is the name of this compound? To get the name of an ester, remember, ester is just alkanoic acid that lost hydrogen, and the hydrogen was replaced by alkyl group. So when an acid loses hydrogen, OH is used as the suffix in the name. For instance, H2SO4, when it loses the 2 hydrogen atoms, we have H2H2 plus, 2H plus SO4, 2 minus. Remember, the name is sulfate. So that is the 8 there is the suffix of the name. Now, if we have H here, that is alkanoic acid, 2 carbon atoms, ethanoic acid. If we remove H, it becomes ethanoate. 8 there. Therefore, can we now name this compound? To name it, you first name the substituent, alkyl substituent, which is methyl. Then how many carbon remaining? 2. That is ethane. But this is not actually ethane. You remove E and put what? OH. So the name is methyl ethanoate. Methyl ethanoate. Methyl here, ethanoate, because of 2 carbon atoms. Okay, let's move to amide. An amide is somehow gotten from an ester. This is ester, general formula for ester. But for this to be an amide, the substituted alkyl group will be replaced with amino group. Sorry, no. For this to be an amide, the OR prime entirely will be replaced with NH2. NH2. This NH2 is called amino group or amine group. So that is why this is called amide. Now let's get the functional group by removing R. We have CONH2. That's the functional group. Okay, let's attach an alkyl group here. Let's still use CH3, methyl. Then CONH2. You can also write this in condensed form, RCOONH2. Also, this one, RCONH2. Also, this one is CONH2. Coming to this, you can also condense it to CH3, CONH2. So, what is the name of this? Remember, there are two carbon atoms, ethane. You remove E because it's not ethane actually. There is an amine group, and this is amine, CONH2, amine. So this is ethane. You put amine at the end when you remove E from ethane. So the name is ethanamide. Ethanamide is the name. Okay, let's come to amino acid. Amino acid. What is an amino acid? Amino acid is gotten from arachidonic acid, COOH. But this particular carbon is called carbonyl carbon. And the carbon next to it is called alpha carbon. This is called alpha carbon. So, at alpha carbon, there is amino group. That is why amino acid is otherwise called alpha amino carboxylic acid. Because carboxylic acid is also arachidonic acid with a long carbon chain. So, this is alpha amino carboxylic acid. Alpha amino carboxylic acid. We have H here, then our arrow here. This is the general formula for amino acid. Remember, amino acid is the end product of protein digestion. That is the general formula. Okay. You can condense this formula as RCH bracket NH2. Bracket shows bonding. Then COOH. Same thing. Now, functional group is when you remove R. You have CHNH2, COOH. Let's create a member. You can create a member by putting the same methyl group, then CHNH2, COOH. So what is the name of this? There are 3 carbon atoms, but this is number 1, this is number 2, this is number 3. You can call this alpha amino, because this is the alpha carbon, close to carbonyl carbon. Alpha amino, 3 carbon atoms, propane, but this is not actually propane. You remove E and put oic acid. So the name is alpha amino propanoic acid. You may not want to put alpha. You put 2 because that is the second carbon atom where the amino group is. So you can call this 2-amino propanoic acid. 2-amino propanoic acid. Okay, so next time we are going to continue with a few homologous series remaining. You have a nice day.